Hey, I'm Samson Timoner. I'm a computer vision guy, and today we're going to talk about using computer vision in WebRTC. In particular, we want to talk about remote teams. So I'm curious, show of arms in the room, how many people work in remote teams? About half of you guys. So about 10 years ago when I started my first company, everybody was in one office. That was really the only way we functioned. And nowadays, I have friends with 10 and 20 people companies with 2 offices, sometimes even 3. We have such a struggle for talent that having teams work effectively together remotely is really important. So today, what's brought about the founding of Cyclops, and one of the co-founders are, it's really this fragmentation of teams across the country. It's really, how do you make teams work effectively together? And so I'm going to talk more about that than the actual WebRTC today, but it's something near and dear to my heart, something I certainly struggle with. In my first company, I ended up with some guys in North Carolina, in New York. We were based in Boston. We had a small team in Asia we were working with. I gotta tell you, it was painful. Video conferencing was useful, but didn't get us all the way there. And so Cyclops is a company that's all about trying to figure out how to make teams collaborate more effectively together. And so it's this fragmentation of talent that's really taken off, and being a computer vision guy, advances in computer vision that we can really take advantage of to try and reimagine collaboration. And so we're going to start off with a really simple and important problem, which is collaborating around physical writing surfaces. I'm curious, another show of hands, how many of you are big whiteboarders? Good fraction of the room, I'd say 30, 40%. So I'm a big whiteboarder. And when I get my team in a room, somebody's up at the whiteboard, we're drawing diagrams, we're drawing data flows, we've seen some great debugging pictures today, and we're trying to figure out how a system really works. But if you ever point Hangout or Skype at the whiteboard, it's really tough to read it remotely. And so one of my key tools, brainstorming all around the whiteboard, I'm just not able to do it remotely effectively. So that's what we're going to talk about today. So this is a picture of a whiteboard, nothing particularly special about it. If you look at some of the areas on the left, it's really fuzzy. The red looks out of focus. And let's just show you what we can do with that. And let's see if I can do a before and after. Yeah. There's a before, and there's an after. So see how sharp the red is on the corner? We add a zoom window, which you can see a little bit of, so that you can actually see what's going on. But let me take you through the process. So I'll play a video here. So this is my collaborator. You can see my mouse going on in the background, and he's turning on before and after. And you can really see it pop. And he's playing with some of the tools there. So you can see my mouse going in real time, right? We're trying to make this a collaborative experience. I can annotate. You can see what I'm interested in, what I'm focusing on. I can add text. He can add text. So the whiteboard doesn't just become a, hey, see my whiteboard, but it's actually collaborate around it. And at the end, of course, you can take a snapshot and email it to everybody, since you have everybody's email address, or post it to your data platform. So what starts off as a, man, if I could just see my whiteboard, to really make it function, it needs to become a collaborative experience. So we've worked really hard on making that happen. Yeah, let's try that again. And I think we're back at the video. Right. So, we're at mycyclops.co from a desktop Chrome browser. Come try it out. It's very simple. You create a virtual room. You point your laptop at your whiteboard. You can turn the enhancement on and off. Share the URL and just start whiteboarding. So I want to just talk about some of the pieces that really make this possible. So when we're all in a room, and we've gone out and done many, many user interviews. When we're all in a room, usually there's only one person at the whiteboard at a time. So when you're remote, that's still the case. For the most part, it's one person at the whiteboard. But that said, in a room, everybody raises their hand and points, and you can't really do that remotely. So a lot of it is capturing short little messages, so cursor sharing, annotation, and snapshot make the difference between just show your whiteboard and turning it into a full collaborative experience. So a little bit underneath the hood, right? Clearly using the video channel, clearly using the audio channel, and we get to make really good use of the data channel here. Right? We can push data back and forth, small amounts of data, some of it real time, but you can really work hard to share tiny amounts of data to really effectively make that collaborative experience. What we've done on the vision side, so the vision algorithms we worked on, in many ways what makes them exciting is that we found ways to really stuff them into the GPU or the CPU. And for a small number of connections, we've heard about bandwidth limitations and CPU limitations today. So for a small number of connections, you can actually do it all peer-to-peer. So that's what's really been exciting about the last few years. Not only have you seen massive advances in your ability to do object detection, but there are new and interesting ways to really take existing algorithms and make them super fast. And so on a standard laptop, you can do this pretty effectively if you spend a lot of time optimizing. So I wanted to keep this high level. So if you can go to mycyclops.co, we're doing a soft release. Very, very recently we started doing that. So come try it out. Let us know how you like it. We'd love to get your feedback.
Thanks, Samson. Do we have any quick questions for Samson individually? Go ahead, Chris.
Yeah, so I'm curious how you guys are doing the computer vision algorithms. Are you just grabbing the frames from the video and using WebGL to manipulate them?
You really want to take advantage of the GPU and the CPU. Unfortunately, there's no OpenCL available, right? So OpenCL is how you actually just take the GPU and turn it into a full computational device. So what you do is you work really hard to figure out what you can do effectively on the CPU and what you can turn into the shader on a GPU. The shaders on the GPU are really, really powerful, but limited in what they can do. So absolutely, we're taking advantage of WebGL capabilities, stuffing frames in, getting data out exactly.
Yeah. Is there one more?
So is this a special whiteboard that you're using, or is it just somehow you delineate this as the person who's managing the whiteboard? That's the question?
Yeah, so the question was, is a special whiteboard or not?
No, it's right. So, I'll rewind. My first company, we sold into conference rooms. Oops. We sold into conference rooms, and man, like the hardware in the conference room, it's so difficult to use, and everybody hates it. And it's not that it's really that difficult to use. It's that the software on my desktop, it does have bugs in it, but I use it every day. So when there's a bug, I know what the bug is. I know how to dive in and deal with it. But if you go into a particular conference room and the hardware isn't working, it's just killer. You're there to run your meeting. You have no idea. Like, you're not there to start Googling, like, okay, how do I fix this bug, or where's the manual? So, a key premise that we wanted to use was totally off-the-shelf software. In this case, it runs in a browser. There's no plugins. There's no downloads. You're just up and running, right? No special hardware whatsoever. So standard whiteboard, standard markers, standard laptop camera.
Real quick, just curious, what kind of image processing you're doing to make the whiteboard really pop, other than maybe like a sharpening filter?
Yeah, so there are really three pieces within it. So first, it turns out that most laptop cameras are super noisy. So there's a denoising aspect. A second is there's an advanced filtering algorithm. And then a third is there's an object detection algorithm, which essentially is looking for lines and things of that nature. Each of them individually, you know, I don't know that as a vision guy I would think of them as rocket science, but getting them all to work together and being efficient, that's where a lot of work has taken place.
I was just going to ask, in the example you showed, the elements of computer vision, I know the cleanup that you just described is using some computer vision to decide how to do the cleanup, but when you added like, line number 8, that was just an overlay on top of the image, right? So was there anything else that's happening computer vision-wise? Is there any way to like export something to PDF where it's using OCR or some advanced, I draw a bunch of diagrams and somehow that turns into a Visio diagram, or a Lucid chart diagram. Is that in the works, or have you guys thought about that? Is there?
Yeah, actually, my co-founder's big PowerPoint guy, right? One of the things you do is you storyboard out on a whiteboard. So we've actually spent a lot of time thinking about that. Can you make the input to something like PowerPoint be, just draw on a whiteboard? OCR, we've spent a bunch of time with. So there's lots and lots of things you can do. And so, yeah, stay tuned, and we have an interesting roadmap. I think you'll be excited by it.
Cool, thanks.
Did you use WebAssembly to run your board?
So the question was, did you use WebAssembly?
No WebAssembly.
So it looked like most of this screenshots were using static information. Do you do any dynamic processing?
Yeah. So, one of the things that's amazing is, from frame to frame, a lot of the stuff that you care about isn't changing that much.
So not just in noise, but in terms of like gesture recognition or using that for your handwriting analysis and stuff like that, using the velocity?
So it turns out it's really hard to do handwriting recognition just based on gestures. If you watch it from our video, if you set up a video and start watching, like you can't actually see the marker, and especially small motion. So really hard to do that. There's been a lot of research over the years of studying, can you get stroke data out, and how good is the stroke data? I view that piece of the puzzle as research, but once your hand moves away, there's a lot of stuff that's there. And gesture is certainly interesting.
One last one, and then we'll.
So I noticed you capture this. Is that a feature of the product that you can capture the whole video aspect of this, or?
So today we're not offering, total video capture capabilities. There's some interest, and if as we roll it out to folks, if that's really important to you guys, totally feasible to do that. I'm just curious, for those of you who are big whiteboarders, how many of you would want to see a video of your whiteboarding session from beginning to end and record it?
All right. Well,
All right, thanks.
we'll do. Chris has been so quiet. We'll give him one.
Yeah, one more. So I can talk about it, I guess. So you were saying that computationally each client. All right. Fine, I will use this. Computationally, it becomes taxing on each individual client, especially as you add more users to the experience. Have you thought about moving a lot of that processing to the server, and what were the trade-offs, and why did you pick?
Yeah. Great question. I'll just repeat it, which is, do you want to do it on the, on the peer-to-peer connections, or do you want to do it in the cloud? So I think the answer is you want to give as seamless an experience as you can to the user as possible. So we've done a lot of exploring on where to do it and how to do it most effectively. And there are quality trade-offs and all sorts of issues you need to be careful with. So I think for today, I'll leave it as we've done a lot of exploring. We're still out there tweaking, trying to figure out if there's a way we can do it even better than we're doing it today. So I think what we have now works pretty well, and we may well decide that the cloud in the end is exactly where we need to do it.